Hey everyone, this is Unit 8, Lesson 2, last lesson of the year, so that's exciting. So the last video we talked about area and perimeter, so that focuses on two-dimensional shapes. We're going to continue with area, but surface area, and then volume of three-dimensional shapes. So once again, all about the formulas that you're using and making sure you just plug in everything the way it should be. Now with three-dimensional objects, it's a little bit different because you kind of have formulas within formulas. Every capital letter, just like in your area of a regular polygon, represents something else. So like every time you see a capital B, it's the area of the base. Okay, and depending on what shape that is, the base can be defined as something different. But notice there is, like in this one here, there's a capital B and a lowercase b. So those are two different B's. So paying attention to something like that. This is like the base of one of the faces, whereas capital B is the area of the base of the entire object. Let's see here. We have P again. Remember, P is the perimeter. So in a three-dimensional object, because you can't really take its perimeter, it's once again the perimeter of the base. The base is the foundation of these shapes quite often. Let's see what other ones we have here. We have C. It's just because the base is a circle, so remember C is circumference. So same thing as P, only for a circle. So that hasn't really changed. Circumference of base. And that looks like it's really it. I mean, H is still height. It's going to be the height of your object. Oh, L is new. L is slant height. R is still radius. And pi is still pi. So that should be pretty much it. Okay, the volume of an object is the amount that it holds inside of it. It's going to be a three-dimensional measurement. And so like we have this cube here. It's what it will hold inside of it. So how much water, for example, or whatever, can we put inside this cube? The surface area of an object is the outside area of all the surfaces put together. So it'd be like, how much material did it take to make this cube? How much wrapping paper would you need to wrap this cube? So the outside area, when laid flat, it is two-dimensional. All right, so we have prisms, pyramids, and cones and cylinders. And so again, they're all pretty much the same. You're using the formulas to solve them. So I'm going to go fairly quickly after the first couple because, again, it's just math. So a cereal company wants to make a rectangular box with base dimensions of 6 by 3 and a height of 10. So what that means is you have this rectangular prism. And a prism is always named. A prism is named by the shape of its bases. So all of the sides are rectangles in a prism. And then you have two bases that could be shaped something else. So this is a rectangular prism. The dimensions of the base are 6 by 3, so like this would be 3 and 6. And then the height of the prism itself is the distance between those two bases is 10. How much cardboard will the company need to make the box? So how much cardboard to make it, this is surface area. All right, so the surface area of a prism, you can always write down your formula first, is 2b plus p times h. All right. So then we need to identify each of these letters so that we can plug them in. So the area of the base, capital B, is length times width. So that's 3 times 6, which is 18. Capital P is the perimeter of the base. So the base is a rectangle, so 2L plus 2W. So 2 times 3 plus 2 times 6 is 6 plus 12 is 18. That is an accident. And then the height of the prism is 10. You should use pretty much every number on this one. They're not going to give you extra numbers in this when it comes to surface area. And so then we can just plug those in. So 2 times 18 plus 18 times 10 . And I just typed that in my calculator. Your surface area is then 216 inches squared. So again, making sure that you label properly when you're doing these. If the company will fill the box completely, how much room is inside the box for the company to fill the box with cereal? So we're filling. When I fill something up, that's volume. So the volume of a sphere, of a prism, excuse me, is equal to base times area of the base times the height. Right here, prism. And so we already calculated capital B right here. So that's capital B is 18, and the height of the prism is 10. A lot of times you guys learn this formula as length times width times height. This is capital B in this particular case, and so that's why you learned it that way, and that's fine. This generalizes it to every type of prism. So even if we have a triangular prism, for example, which looks like this. Something like that. That is not a very good one. But anyways, where you have these triangular bases, this formula still applies. So anyways, so we're just going to do 18 times 10, so 180, and this will be inches cubed. All right. A company wants to make a box in the shape of a cube. So cubes have all square sides, but it is still a prism because this cube is still, or square, excuse me, is still a rectangle. So here's our cube, kind of poorly drawn. That will hold 512 inches cubed. So this is the volume. It's holding that. It's labeled with a cube of product. How much material do they need to make the box out of cardboard? So we're working from volume to surface area. Well, volume gives us a couple things. Volume is, remember, area of the base times the height. And so we have 512 is the area of the base times the height. Well, because this is a cube, all of these, the length, the width, and the height are the same. And so if we call it x, we have 3 of those. So we can replace the other side with just an x cubed. And you get rid of a cube the same way you get rid of a squared. We're going to cubed root it on both sides, and that's in your calculator. You'll either have like a little x root symbol and you just type in the 3 and then hit second and then that button. Or if you have a graphing calculator, it's under the math function. And so the cubed root of 512 is 8, which means that all of these are 8. All right, so then we can move to find your surface area, which for a cube is even less complicated. You don't have to use that fancy formula. There are 6 sides to this, and they are all 6 the same. They're all 8 by 8 squares. So we have 6 times 8 times 8. All right, so because there's 6 sides, this is the length, this is the width. So essentially 64 times 6, 384. And this will be inches squared. We're talking about area. Okay. So a pyramid is a different shape because the sides are triangular. So you can see here in this pyramid, the base is a square. So this is a square pyramid, but the sides are triangular. But we're still just using the formula. So surface area and volume. Okay, so there's your formulas. And again, it's important to know what represents what here. So when you see H, when it comes to a pyramid, we're going to measure from the tippy top down to the center of the bottom. It should form that right angle. Now that's important because if we draw the rest of this line here, this is what we call your slant height, which is the height of the side that's leaning. And that creates this right triangle, which means that, once again, Pythagorean theorem will probably be utilized. So surface area, we need area of the base, so capital B. Let's label this one. So we have a base edge of 8. It's a square pyramid, so this is also 8. And a height of 3. And so that's, again, the height of your prism. And so the area of the base is 64. Little b is the base edge of your sides. So in this case, the triangle. And so that is 8. Slant height is, again, this leaning height here. And so here's where we have to solve something. So if this is 8 all the way across, this triangle is 4. The height is 3. So this is actually a Pythagorean triple, so L is 5 right here. So a 3, 4, 5 triangle. If you don't remember that, though, you would do 3 squared plus 4 squared. Again, the 4 comes from the fact that this is cut in half, is equal to L squared, and solve for L. You will get 9 plus 16, which is 25, and the square root of that is 5. Okay. So L is 5. And now so we can plug everything in. So 64 plus 4, and we are doing 4 times the triangles because there's 4 of them. And then area of a triangle is 1/2 its base times its height. So 1/2 times 8 times 5. That's where that portion of that comes from. That's your area of your triangles. So 64 plus, this is 4 times 4 times 5, really. Well, 4 times 5 is 20. Times 4 is 80. So 144. This was surface area. So units squared. We don't have a label. All right, the volume, we just need the area of the base times the height. So we have everything we need for that already. So volume is B times H, which is 64 times 3. No, dimension I didn't put over here for some reason. And so, I'm sure I don't tell you wrong here, 192 units cubed. Okay, so sometimes you have to find different things, but it's all kind of done the same way. We have a base edge here of 12. Keeping in mind, again, that's split in half, so this here is 6. We have a slant height of 10. So we already have everything except for the height of this. So we're going to do 10 squared equals 6 squared plus h squared. So 100 minus 36. I kind of skipped a step there. Hopefully that's okay. This is squared, and I need to move it over. So that's 64. So h is 8. Okay. So area of the base is 12 by 12, which is 144. And that's 12 by 12. Little b is just 12. Slant height is 10. Height is 8. So I'll pause the video, go ahead and calculate surface area. Okay, so I went ahead and did surface area and volume. I got the same number for both, which can happen, but it's rare. So not quite sure how that worked out just perfect like that. But it also made me realize that I forgot my 1/3 up here. I wanted to go back and fix that. So this needs to be times 1/3. That actually cancels out your 3. And this should just be 64 units cubed. That's my bad. Yeah. Okay. And then find the surface area and volume given the slant height and the height. So the only difference here is that you have this height is 5, the slant height is 13. You have to find this length in order to get this length. And so you have 13 squared minus 5 squared, because this is C and this is like A, equals, call it your base squared, even though you're going to have to double it for your base squared. And so that should be 12. So 144 equals b squared, so 12 equals the base. Now keep in mind, again, that's here. And so this whole thing is 24. And then I'm just going to pause the video and work out the rest here. Okay, there's everything plugged in. So I will need to see that step when you're doing these types of problems. So make sure you're plugging everything in. Don't just write the answer out. All right, and so for the most part, that pattern just continues. We're just using different formulas each time. So here's your formulas for a sphere. Reintroducing pi and radius. Once again, anytime a circle is involved. So find the radius and volume. We're finding different things here. If the area is 400 pi centimeters squared, so use your surface area formula starting out. So 400 pi is equal to 4 pi r squared. So we need to find our radius first, and then we can use that to find our volume. So dividing by 4 pi, we get 100 is equal to r squared. Take that square root, and r is equal to 10. Then for our volume, and that's centimeters. That's your first answer. You can just plug that in. So 4/3 times pi times 10 cubed. And that won't divide by 3. So we get 4,000 over 3 pi, if we're leaving it in terms of pi. Big numbers are okay, you can see from the second one. If we're getting an approximation, we'll go ahead and divide by 3 and multiply by 3.14. And we get about 4186.67. This will be centimeters cubed. This diagram just kind of shows where that radius is located. And so there's our second answer. That is a really bad 3, but that is a 3. All right, so careful which one it tells you to use. This time we're finding radius and area, so we're given the volume. So we're going to use our volume formula. So we have 4/3 pi r cubed is equal to 2048 over 3 pi. The nice thing about these is when you have pi on both sides, when it's in terms of pi, they can just cancel out. All right, they're both being divided by 3, so those actually both cancel out as well. So that simplified this problem a good deal right from the get-go. We have 4r cubed is equal to 248. Hopefully that made sense to you. We're just going to divide by 4. So r cubed is equal to 512. And then take the cubed root. And hopefully you know how to do that in your calculator. That is 8, which I think we just did that one. We'll probably do the same ones quite often. So that's 8 inches. And then the surface area, we can just plug that back into. We have 4 times pi times 8 squared. Make sure you follow order of operations here. 8 gets squared first. So essentially you're just going to do 64 times 4 and leave this in terms of pi. So 256 pi is your surface area. And that's inches squared. Okay. Cylinders, you just have to be careful. Is it asking for surface area or volume? And use your formulas for cylinder. Okay, so here's your formulas for cylinder. But another way you can write this in the way that I learned it when I was in school, instead of using capital B and capital C, you can just say 2 pi r squared, because that's what B is in this case. It's the area of the circle, plus 2 pi r, which is circumference, times h. Or you could say pi dh if you have the diameter given to you. Same with volume. I always learned it as pi r squared because that is the area of the base times the height. And so either way is fine. Depending on what you're given, it might be easier to use the volumes. All right, so a cylindrical silo has a diameter, and so in this case, again, we're given the diameter, meaning that if D equals 50, R equals 25, half of that, and is 50 feet high. So we know H is 50 also. If it is filled, so we're talking volume, what is the amount of space filled in cubic feet? And so we're using volume here, pi r squared h. And so I'm just going to plug those in. Volume equals pi r squared h, because that's the area of the base. So pi times my radius squared times the height. And I'm going to leave this in terms of pi, so I'm not going to type that in my calculator. So I'm just going to do 25 squared times 50. And so I have 31,250 pi feet cubed. If it does ask you for an approximation, you can either use 3.14 or your pi key. This is approximately 98125 feet cubed. Really bad file. All right, a soda company wants to make a cylindrical aluminum can for their new soda. They want the dimensions as follows: a radius of 2, a height of 5. The aluminum costs 0.01 per square inch. To the nearest cent, approximate how much it will cost to make the can of soda. So this one is surface area because we're making the can out of materials. We have R and H. That is all you need for surface area. It's as big as that formula is, those are the only variables. And so we're going to plug those in. So we have 2 pi r squared plus 2 pi r h. And again, I'm going to go ahead and use 3.14 for pi since we're finding a cost. So once I have this surface area, I need to calculate how much it's going to cost. So I need to approximate that. You also have a pi key on your calculator. Just so everybody's on the same page, go ahead and just use 3.14 for me. It will just make all the answers consistent. So we get 87.92, that's inches squared. And it's a penny for each of those. So just multiply that by 0.01, which just moves your decimal. So it costs about 88, because we're going to round up, cents per can. And actually, line, I'm going to say 0.8792 cents. Because they wouldn't round up that far. They'd probably go all the way out. That way, as you add them, you get a more accurate picture. All right, and that's it for that one. And then working backwards with those, if you are given the volume and the height, you can then find surface area. So remember, volume is pi r squared times h. This is equal to your volume. We know h is 10, so pi r squared times 10 is equal to 160 pi. The pi's will cancel. Divide by 10. R squared is equal to 16, so r equals 4. And then you can find the surface area, because now we can do 2 pi r squared plus 2 r h. So 2 pi times 4 squared plus 2 pi times 4 times 10. Videos get a little long, so I'm speeding up here. We have to just essentially work this out. I'm going to leave it in terms of pi. That's 32 pi plus 80 pi. Treat pi like a variable here. So 112 pi. And that's inches squared. All right. And then last is your cones. Again, get down your form. Remember that L is the slant height and H is the height of the cone. So you can see that labeled in your diagram. But if you don't have a diagram, you'll have to draw one. So this one has a radius of 7 and a height of 24. We're once again missing that slant height, so we're going to use Pythagorean theorem. That will never go away. You use it a lot. It's the one thing a lot of people remember about geometry from if I tell them that's a class that I teach. They're like, oh, a squared plus b squared equals 2 squared. I'm just talking while I'm doing this on my calculator. So you get 625 is equal to L squared. Take the square root of that, which I believe is 25. I don't know why I took that in my calculator. All right, so now you have everything you need, and you just type all that in. So we have pi times your radius times your slant height plus pi times your radius squared. I'm going to leave this in terms of pi. So when I do that, I just multiply the numbers, and then I just add the numbers together, treating pi like a variable. That's units squared. And then I do my volume, so I have 1/2 times pi times 20, times 7 squared, excuse me, times the height, which was 24. Again, I'm just going to do 49 times 12 here, and you can type everything but the pi into your calculator if you need to, but I'm going to leave these in terms of pi. So 588 pi units cubed. And then last one, the cone has a surface area, so we're working backwards here, of 36 pi and a radius of 4. So again, your surface area is pi RL plus pi R squared. Find the volume of the cone. So we need to find H, but first we need to find L so that we can then use Pythagorean theorem. So this is multi-step. So be patient with yourself. We have 36 pi is equal to pi times 4L plus pi times 4 squared. Divide everything by pi to start out, and all of them will cancel. So then we get 36 is equal to 4L plus, go ahead and square that, 16. So 20 equals 4L. We subtract that over. So 5 equals L. All right, so once I have that is 5, this is 4. Then again, I know my triples, so I know that this has to be 3. Obviously, picture's not to scale, but this has to be a 3, 4, 5 triangle. And so you can use Pythagorean theorem, but if you remember a 3, 4, 5 triangle, it will be beneficial to you, especially if you go in the construction field. So 1/2 pi radius squared, so 4 squared, times my height, which we found is 3. I'm going to leave this in terms of pi, so I just have 16. Half of that is 8 times 3 is 24 pi centimeters cubed. And don't hate me, but I just realized I wrote down the wrong volume formula. That should be a 3, which means this is a 3. So I need to redo that. That makes that 49 times 8 is 392. So sorry. I get when I go in a hurry. This is a 3. So those actually cancel, and this is just 16 pi. Okay, so sorry. All right, that is not. So have a good day.